morning, afternoon, or evening, cats and dogs. This video is going to cover numbers 1 through 11 on the Operations on Fractions Word Problems guided notes. This is for any questions that we don't get completed in class or for anyone who's not going to be in class this week. Make sure you have the notes handy. Be ready to work through these questions either on your own and checking them through the video or working through them as you watch the video. So let's begin with question number 1. The average person in the United States consumes 425 pounds of French fries each year. The average person living in Japan consumes 1/5 as much. How many pounds of French fries does the average person in Japan consume? So the important information we have here is that the average person in the United States consumes 425 pounds of French fries each year. By the way, for Mrs. Garcia, it's probably a whole lot more because I love French fries. Someone in Japan is going to consume 1/5 as much. So that's going to be our fractional value. So when we look at something like this, we want to take 1/5 times 425 since it's 1/5 as much. We want to find 1/5 of 425. So I set up the problem as 425 times 1/5. I wrote 425 as 425 over 1, multiply it by 1/5. Gets me 425 over 5, which basically means I'm going to take 425 divided by 5. So you can see my long division here. 5 goes into 4 0 times, into 42 8 times to get us 40. Our remainder is 2, bring down the 5. 5 goes into 25 5 times, so we get exactly 85. So our solution here will be 85 pounds of French fries. So what we know from this is if the average person living in Japan consumes 1/5 as much as the average person in the United States, they are going to consume 85 pounds of French fries. You can also treat this just by recognizing if it's 1/5 as much, you can just take 425 divided by 5, whatever works the best. All right, let's take a look at number 2, because this one goes pretty much hand in hand with the previous question. A car is traveling at an average rate of 50 miles in 1 hour, or 50 miles per hour. How far will the car travel in 4 3/4 hours? So if I asked this question and we didn't have a fractional value, if we said how far will the car travel in 4 hours, that would be easy. You would just take 50 times 4. We do the same thing even if it's a fractional value. So we're going to take 50 times 4 3/4 because again, we're traveling 50 miles per hour over a period of 4 3/4 hours. So I wrote this as 50 over 1 times 19 over 4. That is 4 3/4 as an improper fraction. I cross-reduced both 50 and 4 divided by 2. So the 50 divided by 2 becomes a 25. 4 divided by 2 becomes 2. The math here is not super easy. You do have to take 25 times 19, which gets you 475. So you may need to show the multiplication off to the side. If you know 25 by 20 and then you just subtract off 25, that's also useful. So you get 475 divided by 5. Let me show us our long division here. 475 divided by 2. I feel like I said divided by 5. Divided by 2. 2 goes into 4 twice. Get a remainder of 0. Bring down the 7. 2 goes into 7 3 times to get a 6. 7 minus 6 is 1. Bring down the 5. 2 goes into 15 7 times to get us 14. You have a remainder of 1. So what we end up getting is 237 1/2. So we take these values. Let me go ahead and highlight them in green. 237 1/2. So our final solution, how far will the car travel in 4 3/4 hours, will be, goodness, there's boxes everywhere, will be 237.5 miles, or 237.5 miles. Again, you would treat this the same way if you would be doing 50 miles per hour for 4 hours, but now we have 4 3/4. You just need to make sure to remember that when we multiply fractions, you have to make them improper fractions and then multiply straight across. You do not need common denominators when you're multiplying and dividing fractions. All right, question number 3. It says the landing speed of the space shuttle is about 216 miles per hour. How far does the shuttle travel in 1/3 hour during landing? So we're going to take 216 times a third. This is very similar to the French fry question. 216 miles per hour for a third of an hour. We know it's going to be less than 216 miles. So I wrote it as 216 over 1 times 1 over 3. Gets us 216 over 3. Let's go ahead and do our long division. 216 divided by 3. 3 goes into 2 0 times, into 21 7 times. We get a remainder of 0, bring down the 6 though. 3 goes into 6 twice to get us a remainder of 0. So 216 divided by 3 is 72 miles. Please make a note of the labels on each of these. It says in the question, I'll highlight this in blue, how far will the car travel? So our answer should be in miles. How far does the space shuttle travel? Our answer should be in miles. We have to make sure that we have the correct label on our solution. All right, moving on to number 4. And really these first 4 questions are all fairly similar. So it says Bryce's lawn is 3/4 of an acre. If 8 bags of fertilizer are needed for 1 acre, how many bags will Bryce need to fertilize his lawn? Show your work. So we know that he has a yard or lawn that is 3/4 of an acre, and 8 bags would cover 1 full acre. So we want to figure out what 3/4 of 8 is. So we're going to take our 3/4, multiply it by 8. So 3/4 times 8 is the same as 3/4 times 8 over 1. I just multiplied straight across without cross reducing. It's pretty easy. It gets you 24 over 4. And of course, 24 divided by 4 gets us 6 bags. We should definitely recognize that since his lawn is less than an acre, it should be less than 8 bags. And it is indeed less than 8 bags. All right, let's take a look at number 5. So these aren't really word problems, these next couple, but I thought they were good to mix in here. So number 5 says to evaluate xy in parentheses squared if x equals 1/3 and y equals -3/7. Anytime we're going to evaluate things, it means to get us a number solution. So we want to plug those right into the parentheses, plug them right into the expression, and evaluate it. So I've got 1/3 times -3/7 in parentheses to the second power. 1/3 times -3/7 gets you -3/21, just multiplying straight across. You could also, by the way, recognize that these 3's would cross reduce, and you would end up getting -1/7 squared. -1/7 to the second power is -1/7 times -1/7, which is positive 1/49. Don't forget, a negative times a negative is a positive. All right, let's take a look at number 6. The product of 8/9 and 9/16 is between what 2 whole numbers? Well, take 8/9 times 9/16. Keep in mind that you can cross reduce here. You in fact can get rid of these 9 since you have the same number diagonally. You can get 8/16, which of course reduces to 1/2. So what 2 whole numbers is the product between? Well, it's between 0 and 1 because again, the product is 1/2. You can see I explained slightly, showing the work helps as well. All right, moving right along to number 7. These problems go relatively quickly for us. Kara, Tim, and Vicky are trying to find the solution to -3 1/8 times 2 2/5. Look at their work below. State who is correct, then explain why the other 2 are not correct. Take a moment and look through the work. One suggestion I have when you're working through problems like this is maybe try the problem on your own and see whose solution matches yours. Hopefully just one of theirs does. So in this solution or this problem, Tim's work is the one that is correct. What Kara did was a mistake I see a lot of students make is they just multiply straight across. If you have mixed numbers, you have to change mixed numbers to improper fractions. Again, that's for multiplication and division. In Vicky's work, she did everything correct. You can see it really matches Tim's work step by step until right around here. So you might have noticed, I'll highlight this, for 8 divided by 4, she accidentally wrote a 1 instead of a 2, which is a really easy mistake to make, but it definitely affects our final answer. So you can see in my work, Vicky made a mistake late in her work. When she divided 8 by 4, she put a 1 instead of a 2, which affected her final solution. So you really have to look carefully because sometimes it's just a very minor mistake and those are easy to overlook or miss. All right, question number 8. So this is a good one because we're going to see problems similar to this in the second half of the word problems as well, where you have a total and a certain amount of an item needed for making something or producing something, like we're going to see in this case. You'll see more problems like this in the second half. So number 8 says, how many cheerleading uniforms can be made with 74 and 3/4 yards of fabric if each uniform requires 2 and 7/8 yards? Show your work. So if this question seems difficult, think about this one because you would solve it in the same way. I like to sometimes think of an easier problem that takes the fractions out of it because as soon as we throw the fractions into the problem, it has a tendency to get more confusing for students. So it says how many soccer uniforms can be made with 45 yards of fabric if each uniform requires 3 yards? Well, you would take 45 divided by 3 to get 15 uniforms. So you're going to take the total amount of fabric you have and divide it by the amount needed for each. So in this case, the total amount of fabric I have is 74 and 3/4 yards, and I want to divide that by 2 and 7/8 because that's what I need for each uniform. So take 74 and 3/4 divided by 2 and 7/8. Let me just erase all this. Now it's pretty tricky to change these into improper fractions. I promise that the numbers on your test are quite a bit easier. 74 and 3/4 is 299 over 4. We're dividing that by 23/8. Don't forget to keep, change, flip for dividing fractions. I did cross reduce a bit. It actually reduces the 299 and the 23 both divide by 23. But if you don't recognize that, you can take 299 times 2, which is 598, and then 23 times 1 to get 23. Then off to the side, I did 598 divided by 23. And you can see my work. 23 goes into 59 twice to get you 46. We get a remainder of 13, bring down the 8. And then again, not super easy work, but 23 goes into 138 exactly 6 times. So you end up getting a solution of 26 uniforms. All right, let's go ahead and take a look at another problem similar to this. Number 9. So numbers 9 and 10 are also pretty similar to the last question. A lot of times I'll give you several problems that are very similar in nature in terms of what you would do to find your solution. So number 9, it says a box of cereal contains 15 and 3/5 ounces. If a bowl holds 2 and 2/5 ounces of cereal, how many bowls of cereal are in one box? Show your work. So this again is where we have a total amount of cereal in the box. And we want to divide that by the amount that is in each bowl of cereal. So we're going to take 15 and 3/5 and divide it by 2 and 2/5. Don't forget to change mixed numbers to improper fractions. So 15 and 3/5 becomes 78/5. 2 and 2/5 becomes 12/5. Ignore this line here. That was just my cursor that I accidentally copied over. So I have 78/5 times 5/12. Don't forget to do the keep, change, flip. And my 5s will cross out here if I cross reduce a bit. 78 and 12 also reduce, but if you just multiply straight across, you get 78/12. 12 goes into 78 6 times to get you 72, leaves you with a remainder of 6. So you get 6 and 6/12 or 6.5 bowls. It doesn't have to be a whole number. Sometimes I think people assume that you have to have a whole number. You're just going to have 6 bowls plus half of another bowl. There may be times where it's appropriate to round up or round down for real life situations. I'm okay with you just writing the exact answer here. All right, number 10, a batch of cupcakes requires 1 3/4 cups of sugar. How many batches of cupcakes can be made from 14 cups of sugar? Show your work. So this again is where we want to take our total amount of sugar that we have, and I put it actually second. Sometimes I see students who think, well, I have to take the first number divided by the second. Please keep in mind that division is not commutative. So I want to take the total number of cups of sugar and divide it by the amount that's required for each batch. So that would be 1 3/4. So I'm going to take 14 divided by 1 3/4. 1 3/4 is an improper fraction is 7/4. Don't forget to do the keep change flip. So 14 over 1 times 4 over 7. I did cross reduce both 14 and 7 divided by 7. So the 7 becomes a 1, the 14 becomes a 2. Multiply straight across, and we end up getting 8 batches. Make sure you're very specific with your label. If you don't know what label to put, always go back to the question. It'll say, how many bowls? Well, 6.5 bowls. How many batches? Well, that's going to be 8 batches. We really want to make sure that we have the appropriate label on our solution. All right, so we have one more word problem for this packet, and it's this one. So this says, Jackie, Ken, and Laura are trying to find the answer to negative 5 1/3 divided by 3 5/6. State who did the problem correctly, then explain why the other two did not get the answer correct. Take a moment, feel free to pause the video, and look at the work for these three people and try to determine who is correct and who is not correct. All right, so hopefully you took some time and you figured out who was correct here, and hopefully you said that Jackie was correct or did the work correctly. What Ken did was he changed division to multiplication without flipping the second fraction. So he just took division, changed it to multiplication, and kept 23/6 as it was. That's a problem. It's keep, change, flip. You can't forget that last part. Laura made a mistake that I see students do pretty often, which is cross-reducing before you change it to a multiplication problem. You cannot cross-reduce until you've made the problem a multiplication problem. Otherwise, you'll end up getting the incorrect solution. All right, so I know we went through these first 11 pretty quickly. The main topics I would definitely make sure to focus on are the bowl of or box of cereal, the cupcake question, the uniform question, where you have a total amount and you want to divide it by the amount required for each. I think you'll definitely see questions like that on your test, or a question like that on your test. And even those first 3 or 4 questions, three to four questions, where you had to take a number and then multiply it by another fraction, or take two fractions and multiply them, you could certainly see something like that. I think the hardest thing with word problems is figuring out how to set it up from the start. But that's something that, again, between these first 11 questions and the second half of the word problems, you should get plenty of practice with working through. You also get a review worksheet, so that should also help to give you some practice on the types of word problems you can expect to see on your test. Thanks for listening.